definitions and ways to look at well logs or rocks, either lithostratigraphically or chronostratigraphically or sequence stratigraphically. And what my experience has been is that this sort of interpretation, the chronostratigraphy, works much better, more often, than doing a lithostratigraphic correlation. And a lot of people do a lithostratigraphic correlation, but there's more chance of getting it wrong, your correlation, by doing that. And that's what I hope to convince you of this afternoon. So here we ended up here, a continuous reservoir. Here, a discontinuous reservoir. And one way you can tell the difference is using your biostratigraphy. You look for fossils down here in the shales just below the sand. And if you get some fossils down that are the same at both wells, then probably this correlation is correct. But if you find that your fossils, for example, are older here and younger here, then this is the proper interpretation. And that's why it becomes important to do the biostratigraphy. So once again, we went through this example. I won't go through it again. Lithostratigraphic correlation versus the chronostratigraphic or sequence stratigraphic interpretation. Now in this case, I had all these little arrows that show a progradation and then a transgression. Well, that's terrible. Drawing. See what I'm trying to draw these things. So you have a period of progradation where your shoreline moves seaward, then a transgression where your shoreline moves landward, seaward, landward, seaward, landward, seaward. And so overall, you've got a marine transgression at this scale. Okay, so you have a marine transgression at that scale. So on our sea level curve, something like that, we get a marine transgression on the rising stage of our sea level, but really you've got a higher frequency of cyclicity of sea level. So actually you'd have to superimpose this higher frequency on the lower frequency. So you get all these little progradational events superimposed on that overall transgressive systems track. So two different scales. Now, so you have overall marine transgression with 4 seaward prograding intervals. Okay, now remember yesterday you did this as a little exercise where I asked you to find the sands, the reservoir sands, and wherever you get these little high amplitudes, that was a reservoir sand. One there, one there, and see how they're moving landward, they're climbing up landward, which is exactly what you see in this cartoon here. Okay, same thing. Now, what do you have in the bottom here? At the bottom of the sequence, well, you've got some sort of a surface, like an unconformity surface, something like that, down there. And so these are all shorelines, okay, where you have progradation, then transgression, progradation, transgression. Now, remember what I said about condensed sections. Condensed sections and their associated maximum flooding surface are usually very laterally continuous, long distance. So, and where should they occur within a stratigraphic sequence? Where should they occur? Here we've got marine transgression. So we have, let me go back to the sea level curve. So let's go back to our sea level curve here. So we've got marine transgression. Marine transgression over here, we'll say, and we've got all those high frequency cycles superimposed on that. And, well, I drew that, I didn't draw that right. Excuse me, let me back up. Okay, what I really should have, how I really should have drawn this, sorry, made a mistake. So you've got all of these higher frequency cycles, and where now, and that's during the transgression, the first part of the transgressive curve, where would your condensed section and maximum flooding surface be? Should it be below or above? Anybody? Should be above. Okay, you've got early transgression, and then, as I said before, you've got your maximum flooding surface and your condensed section at about that point on your sea level curve. Well, can you identify then, knowing that, can you identify the condensed section on the seismic line? What's it going to look like? It's going to look like a continuous horizon. And remember that high stand deposits above the condensed section are prograding. So, can you look at this? Spend a couple of minutes, why don't you? Just look at this and see if you can do a sequence stratigraphy interpretation. Where is the condensed section and the maximum flooding surface, and where are the high stand deposits?
No sería desde acá.
Por eso todo eso.
¿No? Entonces todo ahí sería bien para allá.
This section ought to be a laterally continuous flat reflector, and you have downlapping of your high stand onto that reflector. Oh, well, yeah, you can look at that. It's a little, it's kind of similar. It's another big cycle though. Where's the condenser?
Solamente tenemos que poner esto. O
That
qué
upper
más?
one.
No sé, eso, ¿no?
Yeah, that's the unconformity surface. Where's the huh? That would be above the boundary. You get your, think of that curve, you get your transgression, okay, and then you get your condensed section on top of that, and then your high stand. Yeah, there you go. Alright, that's good, that's the condensed section. Now, do you see the downlap onto that surface?
Es lo único que vamos a poner. No hay. Pintarlo más fuerte, lo que has hecho no se ve.
Aunque aquí, mira, pareciera que se fuera hacia aquí también.
Pero tienes que encontrar unas que
Now, where's the
estén
high stand?
cruzando eso. Las únicas que cruzan.
Rotational high stand. Where is it supposed to be according to this model? Supposed to be above the
Negro, ponle, no se ve
condensed
tan
section.
negro.
And it's progradational, meaning it's downward. The ocean is to the right, by the way.
Yeah, here's the ocean.
Yeah.
I can see this one going up there.
Well, what I meant was up in this one, where's the high stand?
Aquí en esta parte parece que tuviera un pequeño rechazo.
Tienes arriba igual, ¿no? Aquí doblan, ¿no? Tipo bulo bulo.
Ah, sí. Aquí se forma un horse, un grave, cuando hay dos fallas.
Still, you can see the downward onto the condensed section. Yeah, that's your condensed section. That's the sequence boundary. Wait, what are you talking? The one down here that you drew, that's the sequence boundary. Deposited during, or formed during the flowing stage of sea level.
Yes, like will be.
Right, it'll be this surface, right, yeah.
You see all these little ones here, like overlapping as well?
Yeah, well, they're basically, they're moving up.
Yeah.
You know, they're like, just like the picture says.
That one, that one, that one. And here, these ones.
But that,
Tu falla ya las dibujamos.
but you're,
Y estas, ahí se
No
pierden.
importa. Está muy dudoso.
¿Ves? Se ven.
but you can see the different angles. The angle is different. I didn't draw that boundary.
¿Qué son?
No, ese es
Ah.
la que está cargando.
What is it drawn? What's the blue?
Está llorando tu zona.
Right. So that's
Con su
really, it's sediment, it's not water, it's the shale just seaward of the shoreline. These are the shoreline migrated up. So you're right, there's the condensed section. And you see the downlap of the high stand? See the angle is a little different? Right there, see right there, that downlap is right on the condensed section.
Esta sería una, ¿verdad?
Seismic line went further away.
Una y otra.
Two more of those down.
No, esa parece una, todas están aquí.
Esta sería uno, dos, tres, cuatro.
Aquí hay otra parte.
Yeah, right. That's the best one. And if your seismic line extended further to the right, you'd see more of these downlapping. You see the angle? The angle there is a little bit of difference.
Aquí igual parece menos país. ¿Dibujamos?
Y todo. Pero lo que no sé si esto puede ser otro signo.
And that's probably interference. Because you've got a bunch of these. I think that's more of seismic, not optimal seismic processing. But that looks different. And this is real, this one down here. And the difference in the angle is real. And I think this little noisy stuff there, that's seismic misprocessing. Okay, so you got the high stand, where that is? Right, right. And your condensed section, yeah. No, below. The maximum flooding surface is the surface of the condensed section. Okay, so it's the top.
Sismoestratigráfica.
Well, probably not all of it, but all of it would be a transgressive system tract, but only your organic rich condensed section would be kind of just in the upper part there. Yeah, right, around in there, yeah. Now where's your high stand? Remember your high stand is going to downlap onto the condensed section. Right. In a different angle, slightly different angle, and in particular, yeah, right down in there, yeah. That one in particular is good. Yeah, that's your high stand.
So that would be another cycle.
These are all pretty conformable, the reflectors all the way up, so I think that's just one high stand, yeah. One high stand part of the site. Good. Okay, so, yeah, you found the faults. Okay,
Yes.
so where's the condensed section?
This.
Yeah.
Black.
No, not right. This is your sequence boundary, your erosion surface that's formed during the falling stage of sea level. Now you've turned around and you're starting to raise sea level. And you go up to the condensed section, which is this horizontal reflector. Right. And your high stand is going to downlap onto that reflector, and there's a good downlap right there. But notice the difference in angle between this and this. So your high stand is progradational, it's downlapping to the right. Okay? So transgression, your sand's going this way. Regression, you're prograding in the opposite way. Okay?